So coordination compounds. So far what we have seen, we have seen the classification, we have seen the nomenclature. So today we'll discuss about the theories. So total related to the coordination compounds, there are 5 theories are there. One, the Werner's theory. Two, the valence bond theory. Three, crystal field theory. Four, ligand field theory. Five, molecular orbital theory. In these five, we will be discussing only the three. That's Werner's theory, valency bond theory, and the crystal field theory. So these are there in the syllabus, and whatever these two, these are not in our syllabus. So I'll not be discussing these two. We'll be going only with the 1, 2, and 3. So Werner's theory. So what is this Werner's theory? Actually, this scientist in the year 1893 is the one who gave the first attempt to explain how the bonding takes place in the coordination compound. So bonding in coordination compounds. So he's the first scientist who has explained in the year 1893 about the bonding in coordination compounds. First, suppose you can see here, he has done an experiment. He has taken COCl3 and he mixed up with the NH3 and he got he got 4 different colors. One is COCl3 6NH3, COCl3 5NH3, COCl3 4NH3 when he mixed. So these are the different things he got. But if you see here, there is no precipitation of AgCl. So see here, remember this. First you add this COCl3 NH3. Write down these compounds in your notes. I'll explain. Further things we'll be doing it. So first you write down this. So write down all these three. COCl3 6NH3, COCl3 5NH3, COCl3 4NH3. When you mix COCl3 with NH3.
Yes, sir, done. Done, sir.
Okay. Now what he did is, first he has done this experiment and then he continued the same experiment, okay, by adding the excess of AgNO3. So he added excess of AgNO3, okay, to the solutions and he got different results. First, let's take the first one. So COCl3 6NH3, when he added the excess of AgNO3 for this, he got 3 molecules of AgCl. Next one. When he did COCl3 with 5NH3 plus AgNO3, he got 2 AgCl. Next one. He did the same COCl3 4NH3. He added the excess of AgNO3. This is excess. He got 1 AgCl, or you can say 1 mole of AgCl is precipitated. But this is a green color. This one 4NH3 is a green color. If you see, I have shown you one. Okay, one is in green, the other one is violet. So let's take one more. So COCl3 4NH3, this is violet color, plus AgNO3, he got AgCl precipitation. This is a single AgCl he got, but this one is a violet color. Okay, so this one is green, this one is violet. So let's see what happened in all these cases. So can you tell me what could be the reason here different AgCls have given? Tell me. For suppose you see here 6NS3. First of all, you got different compounds. 6NS3, 5NS3, 4NS3. What could be the reason here? That will give 6NS3 will give 3 AgCl, 5NS3 will give 2 AgCl, 4NS3 will give 1 AgCl, which is green. And the same molecule, it is also showing the violet color. What could be this reason? Guess. Come on, guess.
So the number of NH3 molecules present.
Okay, the number of NH3 molecules, what it is doing? So how does this NS3 is influencing the silver chloride production? For suppose you are using 6NS3, it is producing 3 silver chlorides. And here 5. And here 4. That's giving 1. 5NS3 is giving 2. 6NS3 is giving 3. What could be that? So there comes the chemical coordination. So if you see this COCl3 6NS3, how does it will? If you write in the terms of coordination compound, how do we write this one? What is the central metal atom in this?
Cobalt.
Cobalt, right? It is a cobalt. So let's put the square brackets, cobalt. And what are the ligands here?
Fluorine and amine.
In this case, first amine, NS3. There are 6. And chlorines are the counterparts here. So that is Cl3. So when you break down this molecule, how does this will ionize? Can I ionize this compound, this coordination entity? Is it ionizable? This cobalt NS3 6, can it break down into the ions?
No, sir.
Yeah, that is the basic definition we have seen in the early class. What is coordination compound? That's something that cannot lose its identity. Even you try to ionize, this compound will not ionize. It can ionize this and this, but this compound will not ionize. It will not dissociate into ions. This will be intact. That is what the coordination compound definition is. A complex molecule or a complex formula that cannot be ionized into ions and remains like a full entity. That's a coordination entity, right? So this will not be ionizable. Then what is ionizable? The chlorines and this entire compound. So this entire compound and this chlorine can be ionized. So how this will be ionized? It will break down and it will produce 3Cl minus, and this will break down and it will produce 3 plus. Yes or no? So now you will be having 3 chloride. These 3 chlorides will react with 3 AgNO3 and they will form 3 AgCl. Understood? So how this reaction is happening? So this 3Cl, it will react with the 3 Ag. So when you break down this formula, it will turn into Ag plus NO3 minus. Okay, this will break down into Ag plus NO3 minus. Now 3 chlorine ions will react with the 3 Ag ions, silver ions, and it will finally form the silver chloride. Understood? How this has happened? Is this clear or should I explain in detail? Or should I explain again?
So can you explain again?
See. So I have taken the copper chloride 6NS3. If I want to write down in terms of coordination compound, how will I write? First, I'll put the square brackets. In the square brackets, the first rule is you put the metal atom, the central metal atom. In this, the central metal atom is cobalt. So I have placed the cobalt and I need to write down the ligands associated with this cobalt. There are 6 ammonia ligands are there. So I'll be putting 6NS3. And I'll close this box. Okay, now there is a Cl3 is there, the counter ions to balance this. So this Cl3 here. Understood? So how I wrote this one? Banu,
Yes.
you got this?
Yes, yes. Yeah.
Now if I break down this molecule cannot be broken. This cannot be broken. because that's a coordination entity. You try to do ionization, but it will never dissociate into the cobalt and ammonia. It cannot be dissociated. It can dissociate with the chlorine, but this inside square bracket cannot be dissociated. So that's how CONS3 plus 3 formed. And from Cl3, it formed 3Cl minus. So now you got the ions. Now these ion, the 3 chlorine molecule, 3 chlorine ions, it will react with the 3 Ag plus and it will form 3 Ag chloride. So that's how you got 3 moles of Ag chloride when you reacted with 6 NH3. Understood? Banu?
Yes, sir. Yes, sir. But
What about you, Sharon? You're not responding. Are you in the class?
Yes, sir.
Mandara?
yes, sir.
Yeah. So from this, I can state that the ionizable valency in this case is 3. So because it is having 3 ionizable valencies, so there are 3 silver chlorides were formed. Understood? Now see the same thing, how it will happen here. You take this one, COCl3 5NH3. Now how do we write? So here only 5 NH3 is there. So cobalt NH3 5. But if you see the previous classes, you will understand that cobalt will make the ligand of 6 molecules. It needs 6 ligands. So here the NH3 is 5, but I am missing the other one. So in that case, I'll be taking the chlorine as my ligand, the other ligand. So I'll be putting the Cl. Now I am enclosing this in the square brackets, and whatever the leftover chlorines are, Cl2. 2 chlorines were left over. You understood? First I wrote the cobalt, and there are 5 NH3 molecules are there. So 5 NH3 I wrote, 1 chlorine is left because the cobalt will make the bond with 6 ligands. So here 5 ammonia is there and 1 chlorine is there. And whatever out of 3 chlorines, I have utilized 1 chlorine. So 2 chlorines were left. I will put outside the square brackets. Now, if you see this, yes.
So can you repeat again? Why
See, Banu,
chlorine is left?
the cobalt need of 5. Okay, sorry, it needs total 6. If you see the previous class, it needs 6 ligands. Okay. In the previous case, what happened? So we have a total 6 ammonia. So I don't need to use in this case the chlorine. So here it's like this. So all are associated with NH3. So see here, inside 6 NH3 and I put the square brackets, and whatever the 3 chlorines are there, they acted like the counter ions. So this is enclosed and it is having +3 charge, and it is associated this +3 charge with 3 chlorine minus ions. Okay, this is how it happened for this problem. But if you see here only we have 5 NH3. So this is NH3, this is NH3, this is NH3, NH3, NH3. I'm missing the 6th NH3. So I don't have NH3. Instead, I'm using the chlorine. So the Cl.
Okay.
So that's how CONH3 5Cl. This is making. Now it will be having the +2 charge. And outside, I can put 2Cl minus. So of this +2 is, we need to go and calculate this. So that you can see in the previous class. So we are calculating this +2 or whatever the charge that's coming. Okay, the ionic charge on this coordination entity, you can go through the previous class. So I'm not getting into detail here. So now the net charge is +2. And whatever the 2 chlorines are left over, I am writing it outside, 2Cl minus, which is counteracting and balancing the charge. So when I break down this one, I'll be getting into CONS3 5Cl, the +2 charge, and Cl minus charge. So 2 chlorines I got here. Now these 2 chlorines, it will react with the 2Ag. So this compound, it will react with the 2Ag and it will form 2AgCl. So from this, I can say that the ionization valency in this case is 2. Is this clear for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Okay, fine.
Yes, sir.
Yeah. So there will be 2 moles of AgCl are formed in this case. Okay. Next one. Now you see here COCl3 4NH3. So this is the same. Again, I'll be writing the cobalt and there are 4 NH3 are there. So I'm writing NH3 4. Now I'm missing 2. So I'll be taking 2 chlorines. So total 6 were happened. 4 plus 2, 6. So outside, this will be having +1 charge and it will associate with chlorine -1 charge. So when I break down this, I'll be getting CONH3 4 Cl2 +1 and the Cl -1. Okay, so now this Cl -1, it will react with the Ag plus and it will form 1 AgCl. So from this, I can say the ionizable valency in this case is 1. I'll tell you why it is green and blue. Just now you remember this. Okay. So here the ionizable valency is equals to 1. The same here. Here also it will break down the same way because this is, both are same. The color is different. I'll tell you why the color is different because it's a cis and trans association. So the green one, here COCl3 4NH3, here also COCl3 4NH3. So this one also will give 1 AgCl precipitation. Here also the ionizable valency is equals to 1. So from this, you can say that. So here, when we are writing the ammonia and chlorine, the total will be 4 plus 2, which is 6. So here also 5 plus 1, that is 6. Here also, here 6 plus 0. The chlorine is 0 here. So total 6. Understood? So here, based on the ammonia, it will tell how many chlorines are there. We need to see the coordination. Here, the ligand should be 6. The coordination number is 6. So here 6, here also 6. You should know for every central metal atom what is the coordination number. So from this, how can I define the coordination number? Number of ligands that makes the bond with the central metal atom. So in this case 6, in this case 6, but here 5 NH3 molecules and 1 chlorine molecule. In this case 4 NH3 molecules but 2 chlorine molecules. Sorry, 2 chlorine ions. So here the coordination number is 6. Is that clear? What is meaning of coordination number?
Yes, sir.
Yeah.
Yes.
Now try to tell me what will happen if I use the COCl3 3NH3. How many AgCls, how many silver chlorides will be precipitated? Tell me what is the answer for this.
Sir, can you repeat the question?
Now, how many AgCls will be precipitated in this case? Try to make the coordination entity and tell me what will be the ion that present over the coordination compound. From that ion, how many AgCls can be formed? Come on, guys. It's an easy question. Apply the logic. First, try to
Sir,
write
it
down the
won't
coordination.
form.
So Nitya says it won't form. What about the others? Will it form 1 or 2 or 3? Try to write down the coordination formula for this and then try to find out. Come on, I need answer from everyone. Come on, guys, how much time you need? Sharon, tell me what is the answer? In the final exam, you will not be given much time. You will be having only 1 minute for a question. Shrikar, enter answer.
I think it will not come.
Okay. Bono also says it won't form.
The same answer, sir.
What about you, Mandara and Sharon?
Sir, even I think it will form.
Tell me what is the reason, Mandara? Okay, first, Sharon, you tell me what is the formula for this coordination formula? Sharon, are you there in the
Yes.
class?
Yes, sir.
Yeah, respond. Tell me, how will I write the formula? First, what should I do?
Cobalt.
Mandari, first square brackets.
Okay, sir.
Yeah, in the square brackets, what will come first?
CO, sir.
Yeah, the cobalt, the central metal atom will come first. And
Next, amine, sir.
how many are there?
3.
Okay, next.
Cl.
So is it balanced? What is the coordination number for cobalt? 6. So how many are there here? 3 are there. So what should I do now? I need to take 3
Extra
chlorines.
3. Yes, sir.
So Cl3. Now, is there any chlorine left over here?
No, sir.
So there is 0 chlorine. And what is the charge over here? It's a neutral charge. It is neither having positive or negative. So this is balanced. And can I break down this and bring the chlorine outside? Mandara, can I do that? Can I break down this chlorine and bring it outside and form the AgCl?
No, sir.
Why no? Why no? Because the coordination number, the coordination entity is not ionizable. Okay. So this, the coordination sphere, or you can say entity, is not ionizable. It cannot break down into ions. It cannot leave the any ions here. So this will remain like this. You cannot break it. So here I cannot take out this chlorine, or I cannot take out this NH3. So the ionizable valency in this case is 0. And there is no chlorine atoms, so it cannot form AgCl. Understood this? Everyone got this? What is the reason when COCl3, 3NH3, number of AgCl, silver chlorides are precipitated is 0? Is this clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, you can also see here. You can see here. So when I do the electrical conductivity measurement, that means I'll put the electric charge so that in the solution, whatever the molecule is there, it will break down into ions. For suppose if I take NaCl and I put the current, it will break down into Na plus Cl minus. So the same way, if I put the current here, the COCl3 6NH3, it will differentiate into how many ions? Come on, see here. 6NH3, how many chlorines are given here? Plus 3, minus 3. Yes or no?
Minus.
Yeah. So in this case, it has given 3 chlorine ions. Let me write quickly. So you see here, it is cobalt, NS3, 6, 3 plus, and Cl3 minus. So 3 chlorine atoms. The same here. So what, tell me, how many here? CO,
2, sir.
NS3, Cl. This is plus 2 charge and Cl minus 2 ions. What about this? COCl3 and S3, 4, Cl2, plus Cl minus. So here 1 chlorine. So you can say from this, So here 3, this is plus 3. Here, this is plus 2. Here, in both the conditions, it is plus 1 and plus 1. Okay, so from this, what the Werner told is, so the conductivity was proportional to the number of ions formed per mole. So if I take this 1 mole, I got 3 ions. If I take this 1 mole, I got 2 ions. If I take this, I got 1. Here also I want. So what he says is the conductivity was directly proportional to number of ions. That means if the number of ion increases, the conductivity increases. Remember this. If I increase this, this will increase. So it is directly proportional. Yes, Banu?
So why did we take COCl3, sir?
I didn't get you. Yes?
So here, in this third one, sir, CONH3 whole 4 we can take.
Sorry. I wrote this wrong. My bad. Thanks, Banu. So this is CONH3 4Cl2 plus Cl minus. Okay. So here the conductivity you increase, the number of ions increases. That is what the scientist told here. The Werner theory, he proved that. He concluded that. And remember, different complexes will be showing different ionic valency behavior. For suppose you can see here, this is the valency plus 3, here plus 2, here plus 1. These two are plus 1. And you can also see the conductivity charge. So this is 390. Whereas here it is 261. Here 102, here 102, because both are releasing plus 1. And here only 1 ion, so the conductivity is 102. If I increase that plus 2, it is 261. When I increase to plus 3, it is 390. So from that he stated, you increase the number of ions, the conductivity also increases. Is that clear? So
Yes,
this
sir.
is what he concluded. Okay. So what he concluded from this is, so the atoms within the square brackets will form a single entity. That means, for suppose you take a Na, can you break down this? You cannot, because this is a single entity. But you take NaCl, you can dissociate into Na plus Cl minus. Even the same way here, you take any compound, this one CONH36, you take CONH36, this will be acting like a single entity. It will be same like a Na, where you cannot break down the further Na, the same way you cannot break down this further. That's what he says. So the atoms within the square brackets will form a single entity and they will not dissociate. That means you cannot break down this into CO plus and NH3 minus. You cannot do that. So from that, what the Werner has concluded from this theory. So the atoms within the square brackets will form a single entity. And do not dissociate under the reaction conditions. Is this clear? What is the experimental proof the Werner has given?
Yes, sir.
Yes, sir.
Okay. And remember, the Werner used to call that as a secondary valency, which we are saying the coordination number. Okay. So whatever the coordination number is there. Okay. We'll discuss this in the coming slides. So just understand this one, whatever that he concluded. So you can see here different compounds that are present. So yellow CONH3 6 plus 3 3Cl minus. Okay. So if you see the electrolytic ratio here, so if you see the electrolytes ratio, or you can say the solution conductivity when it breaks down into ions. So here how many compounds are there? This one. So this will be one entity, right? And this one entity is associated with 3 chlorines. So the ratio with 1:3 electrolytes. See, here it is made up of so many atoms, but I'll not count them as individual. This entire thing is like a one unit. So that's what they make, like a single unit, single entity. So here it is 1:2 electrolytes. Here 1:1. Here also 1:1. Remember, this is the final thing that he stated. So atoms in square bracket do not dissociate. Remember this thing. So whatever that you put in the square brackets, they cannot break down. Now let's see what is the reason between this having the green and violet. See the different colors for COCl2NS3 for the plus charge. The reason here is even they have the same chemical formula, but geometrical, they shows the geometrical isomerism. Remember this. So they have a same formula, but they have a structural difference. So same formula, but structural difference, we call that one as geometrical isomerism. Remember this. So what happens? So one is showing the cis, or you can say this thing is also said to be the cis and trans configuration. You know, right? What is cis and trans configuration? Remember or not? See here, one will be the trans position. The other one will be the cis position. So this is cis position. This one is trans position. So what happens with the trans position and cis position? So trans position, where the chloride ligands are there, whatever this Cl2 are there, they are present in the opposite side. If you see the cobalt, here the chlorine is present in the opposite way. Then we call it as trans. If they are present adjacent to each other, then we call it as the cis position. Remember this. Okay. In trans position, the chloride ligands are opposite side. So because of that reason, it's giving the green color. Whereas for the cis position, they are present in the same adjacent side. So chloride ligands, they are present on adjacent side. So these are giving the violet color. Understood? Is this clear? Any doubts?
No, sir.
No, sir.
No, sir.
ఎరా శ్రీకర్ నీకు అర్థం కాలేదా?
No, sir, understood.
మరి ఎలా చెప్పడానికి?
Sorry, sir, I'm writing.
So next one.
Sir, could you go wait?
Yeah.
None, sir.
Okay. So next one, you see here. So metals in coordination compounds, they show two types of ionization. Okay. So let me write. See, remember this Werner's theory, what the Werner has given from the series, he was explaining two things. One is the bonding, and the second one is how these structures are aligned. So structures of coordination complex. So these are the two things he was trying to explain. So one is about the bonding and the other one is the structures of coordination complex. So from that, he has given two postulates. Okay. So metals in coordination compounds shows two types of valencies. Or you can say two types of linkages. So that means we are talking about the bonding. So it will show two types of valencies or linkages. So what are they? So first one is primary, or you can say primary or ionizable. That means they can break down into ions. Or the second one is secondary or non-ionizable. Now the question is for you. So which one can dissociate and which one can't dissociate in the formula of the coordination compounds? Tell me. So which one can break down and which one can't break down in the coordination compounds? Come on guys, tell me. What is the answer?
So the ones which have counter ions can break down and ones which does not have.
So there comes under which one? Primary or secondary? Counter ions.
Primary.
Yeah. So let me take you an example here. So we have a cobalt NS3 6 3Cl minus. Yes or no? This is correct, right? So if you see here, how does the bond has happened between cobalt NS36 and with the cobalt and the chlorines? Okay. So can I break down the cobalt and NS3? I can't break down, right? That's what the coordination entity means, which cannot be broken and which will present like a single entity. So here the bond between the cobalt and NS3 can never be broken. So it will be present together always. It's like a bond forever. So this and this will comes under the secondary valency or non-ionizable, where the bond cannot be broken and they cannot be formed into ions. Okay. And if you see the cobalt and the chlorine, these can be easily dissociated. Okay. They can easily be turned into ions. So this will turn into +3 and this will turn into -3 chlorine. 3 chlorine minus ions. So I can say that the bond between this coordination entity and the chlorine, it is the primary valency, and the bond between the cobalt and the ligand, it comes under the secondary valency. Understood this? What is meaning of primary valency and secondary valency? Is this clear?
So could you repeat?
Yes.
See here, whatever the bond between this cobalt and NS3, I cannot break down these bonds. See, the basic funda of this coordination compounds is this is a single entity where you cannot break. That means I cannot break the cobalt and the NS3. This bond cannot be broken and they cannot be dissociated. So they always, you put anything, you try to do the ionization, but these can never be dissociated. The cobalt will never leave the NS3, NS3 will never leave the cobalt. They are like bond forever. So they are present like a single entity. For suppose, can you break down the Na further? Can you break down the Na further? Sodium. Come on, tell me, Shrikar.
No, sir.
This is a single entity, right? But can I break down NaCl?
Yes, sir.
Yeah, I can break down into Na plus Cl minus. The same way, whatever this square brackets thing is there, it cannot be broken further. It's like a single unit, single entity. But if you see this cobalt NH3 6 with a 3 chlorine, the counter ions, I can break down the bond between this and this and this. So I can dissociate them and form +3 and 3Cl minus. So the bond between the coordination entity and the counter ion, we call it as the primary, which is a ionizable, broken. Ionizable means the bond can be broken and turned into ions. Like NaCl. This is ionizable, which can break down into Na plus Cl minus. But you take a chlorine, it is not ionizable. It cannot be broken further. So that's what it says. Is that clear?
Yes, sir.
So see here, that is what the primary and the secondary. Primary, we call it as something that can break down into ions, and secondary, we say something that cannot be broken down further. So you see here, this is non-ionizable, or you can say secondary, and this is ionizable, you call it as primary. So if I want to write down in terms of definition, so first primary valency, I'll explain in detail, just know this, okay? So you can say the primary valency, it means it corresponds to the metal oxidation state and satisfied by counter ions. Or you can say the negative ions. Here you can see the negative ions are chlorine. So the bond, this means the bond between this coordination entity and the chlorine. So is ionizable. That's what the primary valency means. Whereas the secondary is, it represents the coordination number. So represents coordination number, and this is satisfied by ligands directly bonded to the metal. Whereas here it is not directly bonded. Okay, so it is they just came together because they have opposite charges and opposite charges attract. But here the chlorine is not directly bonded to the cobalt. This entire entity is having the positive charge. To this entire entity, the chlorine is attracted. Okay, whereas here the NH3 is directly bonded to the cobalt. So satisfied by ligand directly bonded to the metal. Is this clear? Any doubts between the primary and secondary?
No,
No, sir.
No,
Clear.
sir.
Yeah.
Yes, sir.
So see here, the cobalt NS3 6 Cl3. So in this, the primary valency, can someone tell me what is the primary valency in this? How much? What is the primary valency in this? Tell me what is primary valency? How many bonds are there in this primary valency?
So 3.
Yeah. Okay. So primary valency means the bond between this entity and the chlorine. So you can say the primary valency is +3 and it is satisfied by 3 counter chlorine ions, 3 counter Cl ions, or you can say the counter ions. Tell me what is secondary valency? Nitya, you don't say. Let's others say. So what is secondary valency in this? Come on, guys, tell me what is secondary valency. How we define the secondary valency? Coordination number. So what is the coordination number in this case?
6.
Yeah, that's what. Okay. So here the secondary valence is 6. That is satisfied by only one molecule, that is NH3. Sometimes this could be NH3 and chlorines. Sometimes it's only NH3. We saw. So that's what I told you. So Werner also stated that, yeah, here I think, yeah, he also stated that the other thing that Werner said is whatever the secondary valence is there, now in modern terms, we call it as coordination number. Remember this. That's what he said. He told at the time that is secondary valency. Now we changed it as coordination number. Is that clear? So this is in modern terms, and this is what. So this
And
is
sir, primary valence is equal to oxidation number.
yeah, you can say that. So this is in modern terms. This is what the Werner has stated. Sorry, I wrote reverse. So this is what Werner has stated, and this is what in modern terms we call it as. Okay, is that clear? So see here.
Yes.
So 6 satisfied by NH3 molecules. And remember in this, whatever the chlorines are there, these Cl minus ions, they are present outside the coordination sphere. And they are called as the counter ions. Okay. And remember, the secondary valency is very, very important. Why? Because this secondary valency will give the structural arrangement. This is what another thing that Werner has given. So what does that structural arrangement means? It will tell the direction and also determine the spatial arrangement. So direction and determine spatial arrangement. Or you can say the spatial geometry. So remember this. So what does that mean? So we got a we have seen, because we have seen there is a octahedral shape. There's a tetrahedral shape. There is a square planar. So all these shapes were determined by the ligands that are present inside. It will not be determined by the chlorine counter ions that are present outside the coordination sphere. So remember, the spatial arrangement, that's octahedral or tetrahedral or square planar, it will be determined by the ligands. It will be determined by the secondary valency, not by the primary valency. Remember this. So these are the common geometrics that are present. Okay. So one is a octahedral. You can say octahedral means it is 6. If it is tetrahedral means 4. Square also the 4. But here the square arrangement, here the coordination number is 4, but it's a tetrahedral arrangement. So remember, here 6 means the coordination number. So coordination number means what? The secondary valency. Understood? Is that clear?
Yes.
So see here, what is primary valency? Primary valency are normally ionizable and are satisfied by the negative ions. Or you can say the counter ions. Okay. So you can see the example. If I write Mn S2O6, which is counter ion with Cl2. So in this, what is the primary valency? What is the primary valency in this case? What you guys are thinking? Yeah, that's it. So 2 chlorine ions are balanced. So here this is the primary valency. What about the others? You got it. Why the primary valency is 2?
Yes, sir.
Yes, sir.
Okay. So next one. Secondary valency. Tell me what is the secondary valency in this case?
So 6.
Six.
6.
6. Okay. So see here. So remember, this is means non-ionizable and it is satisfied by ligands. Whereas here, ionizable satisfied by counter ions. Okay. And remember, here the primary valency is not so fixed, but you can say the secondary valency is a fixed. It is always equal to the coordination number. So remember this as well. So you can say secondary valency is equals to coordination number, and this is fixed for every metal. That you should know. Okay. So for every metal ion, you should know what is the valency for the cobalt, what is the valency coordination number for iron. So you should know. For sodium, you should know. So fixed for metal ion. Remember this. And one more thing. So in terms of modern formula, or you can say the modern formulation, so this spatial arrangement, it is also called as coordination polyhedra. Remember, it's another name for that. So coordination polyhedra. And remember, again, you know this, but again, I'm telling it. So remember, whatever the chemical species are there inside the square bracket, or you can say inside square bracket or within square bracket. So they are said to be the coordination entities. I told you already, but I'm explaining it again. So just know this. So what are coordination entities here? MnH2O6. These are called as the coordination entity. That's something present within the square brackets. Okay. And remember, these coordination entities, they are balanced by the counter ions. So which is balanced by counter ions. So you can say the coordination entities, or you can sometimes they also give in the questions like complexes. Don't confuse, both are same. Coordination entities or coordination complexes. So next one, what is the difference between the primary valencies and the secondary valencies? So primary valencies, it is equals to oxidation number of the central atom, whereas the secondary valency, it is equals to coordination number. Okay. So remember, what is meaning of oxidation number? Oxidation number. That means when you break down, it will turn into, or you can say like this, the electron sharing capacity. Okay. So it's a fundamental thing, or you can say the number which tells about the electron sharing capacity of an element. So which can turn into ions. Remember, this can turn into ions. Okay. Whereas here it is equals to coordination number and it cannot break down into ions. Okay. So that means you can say here the central metal atom bound to ligands. You can say that bound to ligands. The capability of the central metal atom bound to ligands, we call it as the coordination number, or you can say the secondary valency. And remember, this primary valency is not directional. I told you the direction is given by the secondary valency, not by the primary valency. So that's how the secondary valency will determine the structure, whereas the primary valency, it will not determine the structure. Okay. So remember this primary valency, it will not exhibit the directions. Okay. So non-directional behavior is seen in the primary valencies. There is no specific spatial orientation for primary valencies. There will be specific spatial orientation for the secondary valency. Remember this. No specific spatial arrangement in forming bonds. it will gives spatial arrangement. That means how these are surrounding the central metal atom. There is central metal atom, and these whatever the ligands are there, those ligands will arrange around this central metal atom, and that will determine what is the spatial arrangement of this, whether it's a square or the other things, tetrahedral or something like that. Okay, and remember, primary valency it is ionizable, whereas the secondary valency it is non-ionizable. Ion, that means what? Break down into ions. That's what the ionizable means. So how does this breakdown will happen? By losing or gaining the electrons. Okay, so losing or gaining electrons. If something is gained the electrons, then it will be having negative charge. If something lose the electrons, it will be having positive charge. Remember this, if you don't know. So losing will form the cations, whereas gaining, it will form the anions. So this clear? So these are the things, different things the Werner has explained. So Werner theory is clear? Any doubts in this?
No, sir.
Okay. So these things are okay, but Werner has failed explaining few things. There are some limitations are there in the Werner's theory. So what are those limitations? First, he couldn't explain why only certain elements possess remarkable property of forming coordination compound. So he couldn't explain this. That means if you see, not all the chemical elements cannot form into these coordination compounds. Only certain elements they can form into the central metal atoms. So why that? Why could be the reason for that? So he couldn't explain that. The second thing that he couldn't explain is why the bonds in coordination have that specific direction, have directional properties. He couldn't explain that. What could be the reason? He couldn't explain. So why they are only arranged into particular spatial arrangement? Why can't they just arrange into some other different shapes? The third thing is why the coordination compounds have characteristics, magnetic and optical properties. This we'll discuss later in the coming theories. So just know this. So why they have characteristic magnetic and optical properties. He also couldn't explain these three things. Okay, this third one. Is that clear? What are the limitations in the Werner's theory?
Yes, sir.
Yes, sir.
Okay, fine. So tell me, what is the answer for this? This is the first thing that we discussed.
Sir, option B.
So Shrikar says it's option B. What about the others?
Sir, it's option B.
Yes, sir.
Okay, fine, perfect. So see here, the answer is the option B. So why the option B? Let me give. So first one, it's a COCl3 6NS3. This we call it as hexaamine complex. That means 6 amines are there. So hexaamine complex. So first one, hexaamine complex. That is COCl3 6NS3. So if you see how the reaction happened here, that we have seen in the previous case. So when this COCl3 so this Cl3, it reacts with 3AgNO3. So this will form CO NS3 6 3 plus 3 AgCl plus 3 NO3 minus. So if you see here, there are total 3 3 are formed here in this case. Because 3 chlorine counter ions are there, those 3 chlorine counter ions will react with 3 Ag when you use the excess of AgNO3. So that's how it is formed into 3 AgCl. So the first one is the 3 AgCl. So let's see the second one. So the second one, it is having 5 NS3. So we call it as the pentaamine complex. So this one, COCl3 5 NS3. So if I write, this will be plus AgNO3. It will be forming CONS3 4. This will be plus, and it will be having 2 AgCl, right? So the third one, it is having COCl3 4NS3, which is tetraamine complex. Okay, so the tetraamine complex, it will be forming AgCl. So is this clear?
Yes, sir.
Understood or not? Only Shrikar understood. What about the others?
Understood.
Understood, sir.
Wow, what a nice yeah. So you guys are listening so carefully, very attentively, right?
Yes, sir.
Yeah, Sharon, I can see that. So what I wrote here, is this clear? Is this correct? I wantedly make a mistake so that I thought someone could ask this. So here 5 NS3 is there. I wrote 4. And I just showed here plus is I showed, but I said 2 AgCl. Even for that, you said yes. So attentively, you are listening. Shrikar, first you said yes. Great.
Sir, I said yes for listening.
Come on, guys. When I do just process that information, chemistry is you need to take that information in brain and process it. Why this happened? Why that happened? Then only you will understand. It's not bio subject like, okay, listen like a story. I thought someone would raise. At least I thought Nitya will ask the question. Why, Nitya? You're feeling sleepy?
No, sir, this was already there in my book, sir. So I was seeing that I didn't notice what was there on the board.
Fine. So see here, CONS3 5 Cl Cl2. Okay. So this will be giving +2 charge and 2 AgCls. Okay. I'm not writing the entire reaction. Should I write? Or is it okay? Fine. So you can frame from the first one. Okay. Let me write for this. The third one you guys write. Okay. So 2 AgNO3, it will break down into CO NS3 5 Cl plus 2 AgCl plus 2 NO3. Okay. So you can see here, there will be 2 chlorides are ionizable in this case. So one remains inside the coordination. So that will result in formation of 2 AgCl because 2 chlorines can only form 2 AgCl. Here 3 chlorines are there outside the coordination sphere. So that can form 3 AgCl. Whereas in the last one, it will be CONS3 4 Cl2 Cl. So only one is present outside the coordination sphere. So only one is ionizable. So that will form only 1 AgCl. So the third one is 1 AgCl. Is that clear? Banu, understood?
Yes, sir. Yes, sir.
Okay, fine. Sharan, Nitya, Mandara, Shrikar.
Yes,
Yes,
understood.
sir.
Yes, sir.
sir.
Okay, fine. So next one, this is the some question, tricky question. Looks like unsolvable. So can you guys try it? So whatever the concept that you understood, can you apply on this? The same concept. So far, whatever we discussed, try this one and tell me what would be the answer. So I'll give you 5 minutes time. Try to solve it. This looks like very hard, and you can, when you see the first itself, you can skip the question, but it's our easiest question. తింటానురా. చూద్దాం, ఏదో ఒకటి చేసుకుందాం. ఏం తిందాం? చెయ్యి, నిన్న ట్రై చేసావు కదా. రే, లేవనుకుంటే ఎగ్స్ తేవాలి. మార్ట్ క్లోజ్ అయిపోయి ఉంటుంది ఇప్పుడు. సరే,
So will it be option A?
so Nitya says the option is A. So what about the others?
So option D, sir.
Which option? D for dog or B for ball?
D for dog, sir.
Okay, Banu says the option is D. What about the others? Sharan, Srikar, Mandara.
Yes.
Sir, I don't know what to do, sir.
I'm
What
trying.
you don't know
sir.
how to do? ఏంట్రా ఆన్సర్?
Sir, could you give hint?
రే, క్లాస్ అవుతుందిరా, ఎందుకు వినిపించదు? Okay, so I'll be giving you the hint here. So first find out So see here, we have a two compounds. Okay. So tell me what is there. Just know that, find out what is the ionization. And here it says 0.02 moles of CONS3BrCl2 and 0.02 moles of this are present in 200 cc of solution X. The number of moles of the precipitate Y and Z are formed when the solution X is treated with silver. That means this is X. And this one, once again. Okay. So yeah, this and this solution is present within the one solution, that is X. Okay. So remember, this is having two compounds. One is silver NS3 5BrCl2. This is one coordination compound, and this one another coordination compound. So one is giving Cl2. So that will form 2Cl minus. The other one is giving SO4 2 minus. Okay. Now this X is reacted with excess silver nitrate. That means it reacted with AgNO3, and it also reacted with excess barium chloride. So that's a BaCl2. So now understand, AgNO3 will react with which ion or which ion, and barium chloride will react with which ion. And finally, they will form two different compounds that will be in what ratio. But remember here, this is a Ag2 chlorines, which is 0.02 moles, and here the SO4 2 minus is also 0.02. Now it depends on how many AgNO3s and how many BaCl2s it will react. That's it, right? If I tell more, I'm giving the answer. I don't want to give the answer. Now try again. Nitya, once check your answer. Banu, you also. Whether your answers are correct or not. I'll give you last 1 minute. Now the time is 10:18. I'll give time till 10:20.
Okay.
Sir, I think I made a mistake.
Okay, Nitya, try. What is your answer?
Sir, it's option B, sir.
Option B. B for ball.
No, sir, D. D.
D for dog. Okay. So Nitya says the option is D.
Yes.
Are you sure? The answer is D. Check again. What about others? Sharon, Mandara.
So I tried the came as D.
Okay. Okay. Let me tell the answer. So see here. So what do I have? I have a solution X. What is this solution X is containing? Leave about 200 cc or something. See, the questions are sometimes they are like a manipulative. That means they seem like very difficult, but they are not. So here, whatever the 200 cc of solution X, this is all useless matter. Okay. And here you may think like X, this compound, and this has formed this. So it looks like so heavy. So we tend to leave and skip this question and try for the next one. But yeah, this is the easiest one. First, suppose if you see here, it is having the X. The X is having two coordination compounds. One is this and the other one is this. Okay. So see here, it is having 0.02 moles of CONS3 5BrCl2. And it is also having 0.02 moles of CONS3 5ClSO4. That's one thing. Okay. So see here, we are having 1 and 2 things inside this X solution. So one is 0.02 moles of C1H35 BrCl2. The other one is 0.02 moles of this. Now, if you see, when you ionize this, what it will give? It will give 2 chloride ions. That means 2 Cl minus ions. What about this? It will give only one SO4 ion, because the SO4 will be containing -2 charge. So here only one SO4 will just balance this entire thing. So suppose it is having +2, this is also having +2, but here 2 chlorines are required to balance +2. Here only one SO4 is enough to balance +2, because SO4 is having charge SO4 2 minus. So only one is enough to balance this charge. So you will be having only 1 mole of SO4 2 minus here. Is this clear? Up to here it's clear. So this is
Yes.
forming 2 compounds of chloride ions. Sorry, this compound is forming 2 chloride ions. This compound is forming 1 sulfate ion. Is that clear? So this is forming 2 chloride ions. And this is forming 1 sulfate ion. Okay. Now the thing is, which one will react with which one? So what he said now, the X solution, he was reacting with this. He was treated with the silver nitrate excess, and he was treated with excess barium chloride. I told you what happens when we react with the silver nitrate excess and when we react with the excess. I mean, I told you about this. I didn't tell you about this, but the same thing will happen for the barium chloride as well. We saw AgNO3, what it will do. It will replace all the chloride ions. And here the barium chloride is given. It will replace all the sulfate ions. That you should know. That's a basic organic chemistry. Sorry, inorganic chemistry. So I'll be writing in the next slide. Is that fine? Because here the place is not sufficient.
Yes, sir.
So now we know that there is first I'll write about the chlorine. So we have 2 chloride ions, and each chloride ion, each Cl minus ion, it will react with AgNO3. And what it will form? We saw that each chloride ion will replace one Ag and it will form one AgCl. But you have such like 2 chloride ions. So you will be getting 2 AgCls. Understood? Is this clear? So now the question asks is how many, okay, so how many moles of Y and Z are formed, okay, respectively. That means Y will be this one, Z will be this one. So here chloride, it will form the AgCls. And here Z is for this one, okay, sulfate. Sulfate will react with the barium chloride and it will form the Z1. So now let's talk about the I. This is about the Y. So here 2 chloride ions, it will be forming 2 AgCls. So here 0.02 chloride ions will form, so each 2 into 0.02 moles of this one chloride ions. It will react with AgNO3 and it will form how many? 2 into 0.02 is nothing but 0.04 AgCl. Is this clear? Any doubts in this? So 0.04 moles of AgCls are formed. Is this clear? Shekhar,
Yes, sir.
Yes, sir.
Sharan. Sharan, are you there?
Yes.
Okay. So next one, the compound Z.
Yes, sir.
So now what
Yes,
happened?
sir.
Okay, Sharan. So next one, what happens when you treat this? There will be one sulfate ion is formed. So 1 mole of SO4 2 minus, it will react with the barium chloride. So each SO4 2 minus reacts with barium chloride and it will form the barium sulfate. So whatever this BaCl2 is there, it will turn into Ba plus 2 and 2Cl minus. So this Ba plus 2, it will associate with the SO4 2 minus and they will be forming BaSO4. But here only 1 mole is there. I mean, only one SO4 2 minus. That you can say 1 into 0.02 moles of SO4 2 minus will form 0.02 moles of barium sulfate. So the ratio for the Y and Z is, so for Y it is 0.04, for Z it is 0.02. So what is the option? The
D.
option is D. Understood? See, I'm not taking the ratio. Okay, it's not option B. You can't take it. It's a number of moles. It's not a ratio. Okay, so 0.04, 0.02. That's it. Is this clear? How this question is solved? See, I wrote for your explanation this much, but you can easily solve it there itself. Like, you know, X is containing BrCl2, so 2Cl minus, and this one will be forming 1 SO4 minus. So this will be 0.02 into 2, and this one will be 0.02 into 1. So that's how I'll be getting the answer. I don't need to do this much. Any doubts? Tell me honestly, this question is clear for everyone?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay, then we'll wind here. Let's call off the day. Any doubts?
No, sir.
Okay, then. Good night, guys.
Thank you.
Thank you.
Because
Thanks.